Hello everyone, myself Maruti, welcoming you all to this math session. In this video, I'm going to explain a topic from real numbers. See what the explanation says here. Show that one and only one out of n+2, n+4 is divisible by 3. So he's saying out of 3, any one. Which are the 3? n+2 and n+4. These are the 3. Out of these 3, any one is divisible by 3. Then what is this n? Any number. Let me check it out. So I like to take n is equal to something like 7. Okay, n is equal to 7 I like to take. Then if n is equal to 7, what is n+2? n+2 is nothing but 7+2, which is nothing but 9. If n is equal to 7, n+2 is equal to 9, what is n+4? Which is nothing but 7+4, which is 11. Okay, out of these 3, 1, 2 and 3, which are divisible by 3? Let's check it out. Is it divisible by 3? No man. How can you say? I can write like this as 2 into 3 plus 1. Okay, 7 is nothing but 6 plus 1. 6 is nothing but 2 into 3. Here the remainder, see, this is a multiple of 3. Multiple of 3 plus 1 means the remainder is 1. Means not divisible. This is not divisible. Yes, now if n is equal to 7, if you take the same n here, 7 plus 2 is 9. Now can I write that as 3 into 3? Yes, now the remainder is 0. The remainder is 0. Is it divisible by 3? Yes, it is divisible. Here it is not divisible. Here it is divisible. If n is equal to 7, what is n+4? 7 plus 4, which is nothing but 11. Now, can I write that as 9+2? Yes. Now, can I write this as 3 into 3 plus 2? Yes. This is a multiple of divisible by, this is a multiple of 3, means it's divisible by 3, whereas 2 is the remainder. Here we are getting remainder 1 when divided by 3. Okay, I can write this as 3 into 2 also, right? So here we are getting the remainder 1, therefore it is not divisible by 3. Here we are getting remainder 0, therefore it is divisible by 3. And here we are getting remainder as 2, it is not divisible by 3. Why? Because remainder is 2. Means out of these 3, any one. In the same way, you can take n as any number. If you check like this, out of that, any one is divisible by 3, not all. This is what we are going to prove in this concept now. So, let me come back with the given question for you. Alright, here it says, write equal division lemma. If A and B are two positive integers such that A is greater than B, when A is divided by B, Q is the quotient and R is the remainder. And what does the Euclid say? It is nothing but A is equal to BQ plus R, where the remainder should be always between 0 less than B and greater than or equal to 3 or R. That's what. Now apply the same Euclid division lemma for the word 3. If B is equal to 3, that's what. Applying Euclid's division lemma for A is equal to A only, but in the place of B, let's take 3. Let's take 3. Now what does it become? It becomes as A is equal to 3Q plus R, the remainder. Then what will be the remainders? As I said, the remainder should be less than the B. What is the B we have taken? 3. And the remainder should be greater than or equal to 0. So, what are all the cases? So, here the remainder as it is given, remainder will be less than 3, means 2, 1 and 0. Of course, greater than R, greater than 0. Now, these are the remainders. Now, let us plug in. We check it out with the different cases. Now, let's go with R is equal to 0. When R is equal to 0, what does it happen? That's what let's check it out. So, let's take it as case 1. Okay, when R is equal to 0, this is the case what we are checking. Now what does it become? So it is nothing but A is equal to 3Q plus the remainder is 0. Is it that? Now let us write, if you simplify this, A is equal to 3Q. If you simplify that, it's nothing but A is equal to 3Q. Now, is it a multiple of 3? Yes. So we can say, here I like to call it as n is equal to 3, which implies divisible by 3. Yes. So when n is equal to 3q, n is equal to here, it is divisible by 3. Now let's go for the other cases. Now the same n, let us check it with n plus 2. The same n, let's check it with n plus 2 then. Now when, right, adding 2, so n equals is nothing but 3q. What we got here? N is nothing but 3q. Take plus 2 on both the sides. Plus 2 here and plus 2 here. Now, so when n is equal to 3q, it is divisible. In the case 1, when n is equal to 3q, it is divisible. Now, when 2 is added on both the sides, now is it divisible? No, man. It is leaving the remainder 2. It's not divisible. It's not divisible by 3. It's not divisible by 3 as it is leaving remainder. What's the remainder here? Remainder is 2. So in the first case it is divisible when n is equal to 3q. Now here when n is equal to when we add 2, in the case of n plus 2, it is not divisible. Now let us check in the case of n plus 4. When we are taking, right, of course we know n is equal to 3q, we know n is equal to 3q, let's add plus 4 on both the sides. Okay, we are adding 4 on both the sides. Now can I write 4 as, can I write it as 3 plus 1? Yes. Now can I take 3 common here? Yes, 3q plus 1 plus 1. Now can I write that one as something like 3m plus 1? Yeah, here it is a multiple of 3, but it is leaving the remainder 1, means n plus 4, we got it as a multiple of 3 plus 1, which is the remainder. Therefore, n plus 4 is not divisible by what? 3. So, if you check it out in the case 1, right, it is divisible when n is equal to 3q. Right, it is not divisible when n is equal to n plus, when it is in the case of n plus 2. It is not divisible when it is for n plus 4. It is not divisible here. So out of these 3, only in the case of n it is divisible. It is not divisible when in the case of n plus 2. It is not divisible in the case of n plus 4. Now this is case 1 when r is equal to 0. Now we are going for case 2 when r is equal to 1. Let's check it out. A is equal to 3q plus 1. Now let's consider this a as n. N is equal to 3q plus 1. Now check it out. Is it divisible by 3? No. Why? Because it is leaving remainder 1. So for n is equal to 3q, it's not divisible. Not divisible by what? 3. It's not divisible by 3. Now, as it is r is equal to 1, in the case of n, it is not divisible. Now, let us check it out for what? For right, we know n is equal to, what is the n here? 3q plus 1. What is n here? 3q plus 1. Means n is equal to 3q plus 1. For let us check it out for n plus 2. Adding 2 on both the sides. This is n. We are adding 2 on both the sides. This is n. We are taking n plus 2. Means plus 2 on both the sides. Here it becoming 3q plus 1 plus 2, which is nothing but 3q plus 3. Now if I take 3 as common, it is becoming 3q plus 1, which is nothing but 3m. So n plus 2 is nothing but 3m. Here it is a multiple of 3. Therefore, n plus 2 is divisible by 3. So this means this is valid. Here it is not valid. Here it is valid. Means in the case of n plus 2, that is divisible. Now let us check it as n plus 4. So now we know what is n. Right? N is equal to, what is n here? 3q plus 1. This is n. Now we have checked for n. We have checked in the case 2, n is this. N plus 2 we have checked. Now we have to check n plus 4. Adding 4 on both the sides. Now if I open it, 3q plus 1 plus 4, which is 3q plus 5, I can write it as 3q plus 3 plus 2. I can take 3 as common. Right, here it is nothing but, here it is, oh, I don't think we'll be getting 3 common here. Right, it is right. Here if you take 3 as common, it's nothing but 1 plus 2, which is nothing but 3m plus 2. Now see, I have written 3q plus 1, 4 added, it became 5. I am writing 5 as 3 plus 2. Out of these two, I pick 3 as common. Left over is q plus 1. Q plus 1 means m. Means this is n plus 4. This is n plus 4. Is it divisible by 3? No. Why? Because leaving remainder. N plus 4 is not divisible by 3, as it is leaving remainder r is equal to how much? It is 2. Okay, now in the case 1, only 1. When n is equal, for n it is divisible, not divisible. For case 2, here it is not divisible, here it is divisible, again here it is not divisible. Case 1, only once. Case 2, only once. Now let us go for case 3. We are going for case 3. What is when r is equal to how much? Here case 1 is r is equal to 0. Case 2 is r is equal to 1. Case 3 is r is equal to 2. What does n become now? We know a is equal to bq plus r. A is equal to 3q plus 2. Now consider this as now n. So n is equal to 3q plus 2. Now for n is equal to 3q plus 2, in the case 3, when r is equal to 2, is it divisible? Not divisible by 3. Can you please tell me why? Because it is leaving remainder. It's leaving remainder 2. Okay, now in the case 3, we went for n. Here for n, it is not divisible. Now let us take now for n plus 2. Now we know n is equal to what? N is equal to 3q plus 2. N is this, but we are not trying with n. We are trying with the n plus 2. Adding 2 on both the sides. Now it becomes 3q plus 4. Now 4 can be written as 3q plus 3 plus 1. Now let us take 3 common here. If I take 3 common, q plus 1 plus 1. Now can I write it as 3 into m plus 1? Yes. Now here it is the multiple of 3, whereas leaving the remainder. So this is nothing but n plus 2. N plus 2 is not divisible by 3 because it's leaving remainder as 1. What is the remainder it is leaving? 1. Now here it is not divisible, whereas here also for n plus 2 it is not divisible. For n also it is not divisible. What is the third case? We are going for n plus 4, right? We are going for n plus 4. But now, right, what is n actually? N in this case 3, n is nothing but 3q plus 2. 3q plus 2. Is it clear? Now what shall we add? We shall add 4 on both the sides. Plus 4 and plus 4. Now it is nothing but 3q plus 6. Now I am taking 3 as common. It becomes 3q. Right? It is nothing but, which is nothing but 3m. Right? Now is it nothing but 3m plus 0? The remainder is 0. Right? Means this is m plus 4. Means for n plus 4, it's divisible by 3. So if you check it out properly here, case 1 is r is equal to 0. Case 2 with r is equal to 1. Case 3 with r is equal to 2. In case 1, we are applying all n plus 2, n plus 4. For all of them, only 1 is divisible. Why? Because it is a multiple 3q. Not divisible, not divisible. Here not divisible, by the remainder is 2. Here not divisible as the remainder is 1. In the case 2, when r is equal to 1, right, what we are getting? The first case, it is not divisible as the remainder is 1. Here, it is divisible. When we are adding 2 on both the sides, it came in the form of 3m, means there is no remainder divisible in the case of n plus 2. Right, here when n is equal to 3q plus 1, when 4 is added on both sides, it came with remainder 2, not divisible. When case 3, when r is equal to 2, when r is equal to 2, what does n become? 3q plus 2, here it is not divisible as the remainder is 2. If it is, when we are checking with n plus 2, when 2 is added, we got the remainder 1. Therefore, here it is not divisible. But here when n plus 4, n means what? N is nothing but this, 3q plus 2 plus 4, we are getting remainder 0. Means what? Out of all, it is divisible at only 1 and only 1 is divisible by 3. Hope you are able to understand. In this channel, I have been placing both math and science videos.